Inverse relations and functions. If a relation maps elements A of its domain to elements B of its range, the inverse relation undoes the relation and maps B back to A. Basically, inverses counterbalance each other is what they're saying. Inverses switch your X and Y's. When we talk about functions, it's like addition to subtraction. If I say 3 plus 2 minus 2, the minus undid the plus. It just undid it. And that's what inverses do to each other. So they show the diagram. If you have the relation R, domain to range, the inverse of R is they just literally flip-flopped their domain and range. That's all they did. Flip-flopping the domain and range is what happens to an inverse, all right? So find the inverse. It's pretty straightforward. If I'm finding the inverse of this guy right here, I will literally just switch my X and Y's. That's all I'm doing. On a graph, you'll just, if this is move positive 1, negative 1, then you would do negative 1, positive 1. And so it literally just flips across. What you'll notice is they have this little dashed line here. Speaking of reflections, good segue into this. It reflects across the line y equals x is what an inverse does. And so it literally just reflects it across this line right here because it switches the x and y values. And so your original function will look like this. Your inverse will look like this on a graph. So finding the inverse is just a multi-step process, all right? When you find the inverse, your first step is to switch x and y. So the first thing we are going to do here is we are going to switch our x and our y. So instead of having y equals x squared plus 3, we're going to have x equals y squared plus 3. And then once we switch x and y, we are going to solve for y. All right, and so we will have, subtract our 3, so we have y squared equals x minus 3. And then we need to take the square root of both sides. Now, variables are involved, so y equals positive or negative square root of x minus 3. Typically, when they do an inverse, they will have, instead of having a y here, you would write y to the negative 1. That indicates an inverse. Think about when we did geometry inverse trig functions, sine to the negative 1. That's the inverse trig function. So typically you'll have this negative 1 to indicate that you found the inverse of the original function. That is what you will do. So your typical, they don't do it in our book, but the final step is to replace y with y to the negative 1. Because I do want you to know that, that particular notation. So the critical thinking here at the bottom, the checks understanding, does y equals x squared plus 3 define a function? So the first question is, does this define a function? Would I have a function here? Function meaning one-to-one relationship. So let's look at the graph actually of this guy. If I were to draw the graph of this, y'all should actually know. Someone named what this graph would look like just a few minutes ago. Yes, that is a parabola. Specifically, it's a parabola that got moved up 1, 2, 3, right? And it will look like this. That's a function. I know a couple ways of why that's a function. One, a vertical line test, a pass a vertical line test, right? And I also know that if I input any y, I'm only going to get 1x, right? Any y will give me 1x. However, the inverse of this function is y equals positive or negative square root of x minus 3. Is that a function? No, because if I put in an x value, let's say I put in something like 12. 12 here, all right? So I put in an x of 12, that will yield a y. If it is a function, it should only yield one y. What happens though? 12 minus 3 is 9, and I have this little guy in front of it, positive or negative square root of 9. So 12 will give me a 3, and 12 will give me a negative 3. So on a graph, it would look like this. I would go to 12. I'm not counting, so don't judge me here. So 12, 3, 12, negative 3. That does not pass a vertical line test. So oftentimes the inverses are not functions, right? So you can find an inverse and it not be a function. So we definitely found the inverse here, but the inverse is not a function even though the original one was. You look at the graph here of what we just did. The original graph is my parabola. The inverse, remember I said it reflects over y equals x. And you can very quickly see from the picture that this is not a function. If I were to draw a vertical line, we would have many, many issues. It's a sideways parabola here, is basically what happens with that square root. All right? So let's look at finding the inverse function. Finding the inverse, all right? So it says find the inverse. Consider the function f of x equals square root of x plus 1. Find the domain and range of x. Domain and range of x, all right? So domain, what does domain represent? X's or Y's, input or output? Yeah. So my domain here is going to be my input or my X's, all right? Do I have a limitation on my X's?
Can't be a negative.
My X's could potentially be a negative, but it can't make the inside of that a negative because a negative 1 actually will work, won't it? So what can it be?
Greater than equal to the -2, or less than equal to -2.
Negative 1.5 is okay then?
Less than or equal to -1.
Greater than or equal to -1 is my limitation. So x must be greater than or equal to -1. So basically with a root, you want to figure out what makes it 0, and it has to be everything bigger than that. Right? Okay? Makes sense? All right, what about my y? What about my output, my range?
Can't be anything.
It can't be negative, right? So how do I write that?
Y
Y has to be, how do I write it can't be negative?
equals slash -1.
We want to do it with numbers. Oh, so negative 0.5 is okay?
Y has to be greater than 0.
There we go. Greater than or equal to 0. Greater than or equal to 0. All right. Greater than or equal to 0. All right. So we have our domain and range. So far, so good? Okay. Find, and now they have introduced this notation, f to the -1. That means find the inverse. They've given me my f of x. They want my inverse. So what I'm going to do is I am going to rewrite this f of x as a y. Because my first step in finding an inverse is switching x and y, and there is no y in my function, right? But basically, f of x and y are the same thing. So I'm just going to rewrite that as a y. So my first step is to switch my x and my y. So instead of having y equals the square root of x plus 1, I'm going to have x equals the square root of y plus 1. And I need to solve for y. How do I get rid of that root?
Square.
I need to square both sides, right? So I have x squared equals y plus 1. I need to solve for y.
-1.
Subtract 1. So y is going to equal x squared minus 1. And I need to rewrite this how they originally told me to find it. So I would say f to the -1 equals x squared minus 1. That is my inverse. I have found it. All right? So far, so good? Find the domain and range of this. Find the domain and range of this. All right? So basically, I have x squared is definitely going to be bigger than 0, right? So that means x squared minus 1 will be greater than what? What's the smallest this could be? If the biggest x squared could be a 0, right? Because if I plug in a negative, what's going to happen?
It's gonna come positive.
Right, it's going to become positive. So the smallest it could be is 0, right? If I look at domain and range. Domain really doesn't have a limitation, does it? Do I have any limitations on this whatsoever?
It can't be a negative. No, maybe.
Why not?
Well, domain's what you plug in, right?
Yeah.
Oh, then never mind.
Domain is what I plug in. Do I have any limitations on what I can plug in here? No, I should not have any limitations to what I can plug in, because it doesn't matter what I plug in. So domain really doesn't have any limitations here. Domain can be all real numbers. We're good with all real numbers. But what about range?
It can't
No
be negative.
imaginary.
Okay, so we just said domain can be anything,
Range has
but
to
it will always be positive, right? Because it's going to be squared.
So range can be
be
negative.
greater than or equal to
So-
0.
it's going to be not 0, but x, what if I plug in a 0 for x? What's the smallest my range can be? -1. So my range is going to be, y is going to be greater than or equal to -1. Everybody see that? Yes? All right, what you'll notice is the domain of my original and the range of my inverse are the same. That will always happen. All right, the domain of the original and the range of the inverse will always happen. All right, will always happen. Okay? Now, is the inverse a function? Yes or no?
Graph.
You don't need to graph it. You can think about the graph.
I'm imagining it. Right?
Imagining a graph for this. Is it a function?
No. Wait, what does the -1 on the F do? Does it like turn it off? Or...
Y'all know that. Oh, that's just like saying why.
Oh. So yeah, so it is a function.
Yeah, it looks like this. We drop down to here and we draw a parabola.
Yeah, it mixed me up. I was like, what is the -1?
Do it. So the first thing it's wanting you to do, find the domain and range of your original function. This wants you to find the inverse. Switch x and y, solve for y. Then it wants you to find the domain and range of your inverse. Then it wants you to do a composite. Plug 3 into your original. Plug that answer into your inverse. Plug 2 into your inverse. Plug that answer into your original. So these two are composites of your original and your inverse. All right? The domain of your function was all real numbers. It's a linear equation. It's a line. So there's no limitations on a line. There's no like jumps or anything that happens. To find the inverse, you switch x and y. So you have x equals 10 minus 3y. Subtract your 10. So you have x minus 10 equals negative 3y. Divide by -3. And I just distributed that negative to the top. So that is my inverse right here. This would be my inverse function.
Would you take it if you left the negative?
And then they wanted the composite. So I put the 3 in my original function first. 10 minus 3 times 3. So that equals 1. Then I put the 1 in my inverse function. -1 plus 10 over 3. That's 9 over 3 equals 3. I did the composite the other way. I put the 2 into my inverse. -2 plus 10 over 3. That's 8/3. Then I put the 8/3 into my original. 10 minus 3 times 8/3. That is 2. You will notice a pattern here. The inverse composite with the function of 3 equaled 3. The function composite with the inverse of 2 equals 2. This is always, always true. If f and f to the -1 are inverse functions, then the composite of those two of x always equals x, no matter which way you do the composite. So no matter which way you do the composite, you will get what you started with. That's one way to test to see if you did your inverse right. If you take the composite, you should end up with just x. Your answer should just be x. That's how you test to see if two things are inverses of each other. You take the composite of them. If you get x, you have an inverse. And so they've given us these two functions. For the function f of x equals x minus 7 over 6, find the inverse composite of 374. Please do not go through the process of plugging that in and finding your inverse. The answer there is 374. The composite of the other two of negative 99 pi is negative 99 pi. That's the point of this particular exercise. So when you take composites of inverses, you will always get what you start with, which means you'll always get x when you're just doing the two functions. If you have a number in there, you will always get the number that you start with. Questions on that? Questions? For f of x equals 5x plus 11, find the composite. There we go. It's just going to be those two numbers.